Hello. Let's see if it works. Hi, guys. Have you ever wanted to write a game? And it's not a rhetorical question, I am actually asking. Are any of you failed game developers? Yeah, right here. Yeah, myself, I've done it in every technology I've ever written in. My first game was, in fact, a blackjack bot on IRC. I was far too young to play blackjack, but I don't know why it was my first game. Then I've written some in Turbo Pascal, I remember, in Java, in JavaScript, with React Native as well. It was horrible, but it worked. I eventually went to C# with Unity, which is so much fun. But guys, have you ever tried to write a game for Ruby on Rails? Is it even possible? Let's see how it would look like. There'll be dragons, right? So we have a very simple game, nothing ambitious. I can hit arrows and I can walk around the dragons to finally get my ruby. Simple stuff. I can only imagine that any one of you could write it. So let's see the fun one. Whoa. Everything's moving. And just FYI, it's not in JavaScript. Everything that you see is generated on backend and served to frontend. So the world is actually processing. And on top of that, we can move to avoid dragons and collect rubies. And even on top of that, let me put it down. We can connect another player. Now we have two knights on the board. And the other one can still move. Oh, if you select correctly. So we have a game, and it's written in Ruby on Rails. Let us see how it works. Oh, not this way. So the game logic is performed fully on backend. It's persistent in a database and just refreshed, and it's pulling, the browser is pulling the updated state every now and then. So you get the interaction, you get the constant flow of changes within the world. Oh, sorry. So the movements are basic Ruby on Rails endpoints. Nothing fancy here. But on top of that, we have to make sure that the world is progressing. And for that, we have a game loop. The game loop controls the world, but what it is? A game loop is a process that runs continuously, as you can read. It runs as long as the game is running. It's pretty much while true loop. It gathers input, it calculates what should be the next state, and eventually it renders some outputs. So by joining those two mechanics, like controllers and endpoints for movements and the game loop, that makes the world actually vivid and makes the world going on, we can create a fully functional multiplayer game. and we can do so much more. Hi. My name's Paweł. I work as a software consultant, team leader, consultant, developer at Visuality. And today, to the surprise or delight of some, I won't be talking about domain-driven design. And today I'm going to tell you how to build a multi-process server with Ruby on Rails, which is also fun. But before we get there, we need to answer some basic questions. So the first one would be, how do you check application state every day, like once a day? It's easy. Let's use Cron. Cron is a time-based job scheduler, right? So it's a cron mechanic can be found in every Unix-based operating system. It's just a tool, system-level tool. It can also be used as a beloved Sidekiq extension, like Sidekiq scheduler or for others. And it's often the case in Ruby on Rails, right? So you can say that something should be performed at a given hour, minute or so. So the definition would look pretty much like this. So such a definition of a job with a time, for those who might not be familiar, consists of a time expression. Too many buttons. So we have a time expression on the left, and each position defines like a minute, hour, day, week, and day of a week at the end, and a shell script to be executed at this hour. So in this example, we have a shell script being executed at 2 a.m., 2:05 a.m. So every day we can check system state. Pretty much nothing new here. So let's complicate a bit. And how to check, let's say, a currency rate every hour. That's also as simple as the previous example. We just have to alter our time definition. So we will perform at every hour at 0 minutes this shell script. It gets better soon. So how to check something? Let's say a transaction state once a minute. Well, there is a cron definition for that, like every minute of every day of every hour. But running cron jobs every minute might be problematic. So jobs may overlap. They often might take more than a minute for whatever reason. You might need to throttle to have only one at a time, as they may interfere. And cron is a mechanic that should be 100% reliable. If we say it has to be run at this time, it has to be run at this time. But if you use this system-level cron, you are guaranteed that it will be executed. But most often you guys, or we use Sidekiq for that. And Sidekiq isn't that reliable to execute something at a very set time because, well, it might be just overloaded, and sorry, I can do that. But all in all, it's technically possible to run something every minute. All right, so how to check system state once a second? All right, so let's figure it out. One note, I've had a beautifully colored presentation. Every piece of code in this presentation had beautiful colors and just removed them like half an hour ago because of the projector. But still, I hope it's at least barely readable. It doesn't really matter what's written in here. I can read. It's like a measure state, and unless state is valid, escalate issue. escalate issue. That's all. This is just something that we want to run every second. So pretty much at every second, we want to run this code. Put it in Jira and just do it. So basically, we want to have a loop that execute this code. And for the sake of the presentation, for the sake of the simplification of this code, which is really irrelevant, I've just put sleep 1 in here, which is obviously not the thing that you've just seen, because we should sleep less than a second, because this has taken some time. But honestly, we can do that at the after party. For now, let's just have a loop that has 1 second intervals between executing the logic. So, well, pretty much, we can just wrap it in a rake task, and we are good to go, right? It's solved. This is something that you can run, and that will be executing a system measure or a state of a system every second. Well, for this extremely simple task, it might be good enough. At least it solves the issue. It might not even be that hard to monitor. Is it still running, or perhaps our virtual machine or whatever you're running or pod hasn't exploded. It might be simple enough to measure and check the state and maybe restart. And just to know what's the cost of running something like this, if you are on Heroku, that's $7 for the minimal dyno, and the cost of one pod maybe if you are in a Kubernetes setup. So at the moment, let's say it's good enough. It kind of solves the problem, and let's move on. Let's solve one more task. How to continuously read from a data feed. We already know, right? We have a rake task that, what does it do? It, which button? This one. So it reads some messages, handles them one by one, and then sleeps for, let's say, 10 seconds. Again, problem solved. One thing I really would like to urge you, not to solve this like this. This is, for the ones that cannot read this from far away, it's a Sidekiq job, which executes the same logic. So it reads messages, it handles the messages, and then at the very end performs, hey, schedule me this job in 10 seconds. Now, why? Each job relies on a Redis write and Redis read, right? Because we have to write this down to Redis and then read from it to execute the next job. We cannot fully control the number of the amount of time that will be between the jobs. Sidekiq, well, it's nasty sometimes, and you might just have overloaded queues. And I know it can be, because we had a very insightful discussion before. I know it can be set right, but it's not trivial. And in most cases, Sidekiq is just created like, okay, take the first page of README and it will work. But eventually, you cannot really control the load on your queues. So this might not be 10 seconds. It might not be relevant, but if it's critical, then this is a burden that you have to carry. But the most important thing is something that you can actually find if you read Sidekiq documentations a bit more deeply. This job will execute at least once if everything works. Not exactly once, at least once. By definition of how Sidekiq works, and it's not a flaw, it's the definition of how it works, this job will be executed at least once, which means that it can be executed twice. And if it's executed twice, then we get a fork. Because if it's run twice, then we will have 2 jobs scheduled for future. And it's kind of a deal breaker and yet another reason not to do it like this. And Sidekiq, just to sum up, Sidekiq is just not designed for this kind of operations. And I wouldn't be talking about Sidekiq at all if it wasn't for the fact that all the time-based issues are solved with Sidekiq in Ruby on Rails community. So let's go back to our initial task. So we've had this read feed process. Let's say we want to read a bit more and we want to have 2 concurrent processes. So let's say this handling of message is quite long. Reading, let's create ourselves some kind of concurrent read feed. So let's say that this class concurrent read feed, this is able to maintain this read ability for concurrent processes. So we have a process just as we have a second ago, but now it has this concurrent reader. So we can just run 2 of those, right? And we have doubled the amount of messages that we can handle. And we've speed up our process by 2, more or less. But we've also doubled the cost. If we, for example, want to just deploy it to Heroku and we want to have 2 of those processes. So that's another dyno. So we might say, okay, processes are big. Let's put that into threads. Don't mind the code, it actually works. I've tested it because I've heard one of Chris's presentations that you always have to test your code before showing. So it actually runs and it does the work. So it runs 2 threads with concurrent read and it sleeps for 10 seconds. And so now we've negated the cost of the second dyno, and this actually would run and it would actually read the messages. But what if we get an exception in here? Because we will eventually. How to monitor it and how to resume a failed thread, for example. Those are valid questions in production. Or, for example, how to gracefully stop. We need to deploy from time to time, and this should be stopped, and the kill 9 doesn't really do the work in general. So it gets complex quite quickly, unless you just say, screw it, I don't care. But if you do, it gets complex. So here comes a ServerEngine. It's a framework. A framework to implement robust multi-process servers. It's, by all means, not mine. It has been presented at RubyKagi in 2014 by Masahiro Nakagawa. Here's a YouTube video. It's in Japanese, so it might not be that approachable, but the slides are in English, and the documentation is quite clear because, well, it's open source. So you can go to GitHub and you can read all about it. It works like this. So far, we've been, this is like taken from the documentation ServerEngine, just redrawn. And here it says worker. So how it works. So far, we've been talking about the concept of a worker. So a concept of something that does the work. But in ServerEngine, you can define work for worker and run as many as you like. Those might be run as processes or as threads, depending on your needs. But it's also in ServerEngine, it's also possible to add a TCP server. This server listens for incoming communication, so you can actually communicate with your workers, or you can change the state of your server as a whole by communicating over TCP. But what's most important, at least for my use cases, on top of that, there is a supervisor logic. this supervisor makes sure that any failed worker would be restarted. Because memory, or well, memory especially, or network problems are something you have to be prepared for. They will eventually happen, for one way or the other. They will. And this supervisor mechanic would restart worker without even telling you. Of course, if there is a condition that continues and this worker would be falling again, you have to act. But if there is a one-time issue, you won't even notice unless you have good monitoring. So this is what ServerEngine does. It also allows for dynamic reconfiguration and all that jazz. A simple code example. Again, it was beautiful. Now it's not. So this is actually taken from ServerEngine's repository. How to run it? You define the worker module. You can call it whatever you like. And it just has two methods for now. It has run and stop. And in run, you have this indefinite loop, which just does the worker. And this is a very, very, very simple definition. And how you execute it, you just run ServerEngine, create. You give the worker, and you define some options. As you may or may not read, you can demonize it, so it runs in background. It gives you a log file and a pit file. So you have full-blown server done in like 4 lines of code. You can also add this server that was on in the picture. So again, just as we have worker a second ago, now we have a server defined, again a worker, and we run ServerEngine by passing server, worker, and a bit of params. The most important or interesting one in here is the one workers for. So this is all it takes to run 4 of those workers. Just workers for, and that's it. I bet most of all of you haven't heard about ServerEngine, maybe most, but it is used by some of quite big gems. One of those is Sneakers. This is where I actually found ServerEngine. It's a gem for processing Ruby, RabbitMQ queues. And this Sneakers allows you to run a server and workers that would consume messages from RabbitMQ. And the other one is Fluent. This is for logging. As you can see, Sneakers has like 2,000 stars on GitHub. Fluent is much bigger. It has 12K of those. And on the other hand, ServerEngine has less than 800. It's like unknown in the world. I feel it's quite unjust because it's really, really powerful. All right, so you might get the feeling that using ServerEngine is complicated. Even though it's just like 4 lines of code here, 4 there, you have to actually understand what's a server, you have to figure it out, you have to think about those workers, and so on and so forth. It's not what Rails developers do. We like simple solutions, and we want a gem, and we want to write 2 lines of code and say it's done. So here comes Rails permanent job. It's a wrapper for ServerEngine so that we don't have to think about how it works. It just simplifies the usage so that all of you can run similar things. It's production tested. I've been running it for several months in production, and honestly, everyone has forgot that it existed, that it exists. It runs event consumer. Actually, there is no discussion about it. It just runs since it has been deployed. Raise permanent job is available at GitHub, so take a look if you like. And just a few, again, black and white code examples. Here's a worker. Well, it doesn't have this worker terminology anymore, so it's a job. We want to have a job. Job is something that does something. So this one beeps. So we have a class with a call method. And the only method that we care about is this call. You know the drill. We can have a a rake that would just use it to run our loop. So we call Rails permanent job and we put an array of jobs. I will show you more example in a second. And we just say run. We may pass the number of workers. So this is all it takes to run a server. Again, you can run in for example, Heroku just by running this rake in your proc file. And that's it. You can do whatever you like in here. Let's take a look at another example. Oh, okay, you can, of course, run it and it would just beep. You might notice, if you sit closely, that it runs once a second. So between each beep, there is a second delay, a delay of 1 second. Let's see what we can do with that. So let's take a bit more complicated example. Let's have two jobs, first and second, of course. But so we provide those two jobs to raise permanent jobs and in an array, but also we add something called after job. So what does it mean? After all is said and done, after the raise permanent job executes the first job and the second job, it executes something called after job, which is yet another class with a call method. By default, this is 1 second. This is just sleep 1 second, but we can adjust it and say, let's say, for example, just debug me something and sleep for 3 seconds. The execution would look like this. So now we have doing first job at 40 seconds, doing the second jobs at 40 dot something, taking 3 seconds break at 40 dot something, and then doing the first job again at 43 dot something. Not very creative example, but it at least shows what's after job. As I've shown you in the case of ServerEngine, you can easily define the number of workers that you'd like your code to run on. So again, this very similar example, just a job that does nothing and just sleeps and beeps. But now we run it on 4 workers. And if we execute the example, we can see that there are 4 processes. And each process does the same thing. What I like about the classes with call methods is that raise permanent job actually doesn't care. And it doesn't care what you give it. It just has to have a call method. So we can you can give it lambda, both for a job or for the after job. So just a syntax you might find useful. And maybe one actually useful example, you will find all those examples with this one as well. This is the only real life example in the examples folder. This is AWS SQS consumer code. Is probably found somewhere, or either in documentation or in Stack Overflow or something. But it actually works. I've tested it. You don't have to actually read it, but it just initiates the clients of AWS, and it receives messages from a queue. So we can create such a class, put it into raise permanent job, define the number of the amount of time that we want to sleep between the jobs, and just run it. As simple as that, and it just works. All right. And with that knowledge, let's see how this is implemented. So we have a game loop. This is a class with a call method. It gets logger, and there are a bit more options, a bit like in Trailblazer, because I got my the idea to do that came from there. So we can debug, but that's not relevant. And in the game loop, we have loading the board. It's a simple application. It has only one board. Then we progress it. So in the board.progress, it calculates what the next stage should be. Like, where are the dragons? Where are the players? How many points they have, and so on. And we save the board. And that's it. It's a game loop. Well, it's a game loop, probably not the correct name, because it's just progresses the game by one frame, but nevertheless. We take the class and we create a rake task. You may see that I like rake task. When I want to start a game, I reset the boards. I put the game loop as a job to raise permanent job. As an after job, I say to sleep 0.3 seconds. I can also define the log level, and I just run it. And this is how it works. This is actually copy-paste from the source. I haven't changed a letter. So just a quick summary. Not every problem can or should be solved with Sidekiq. If you have any experience from outside the Ruby on Rails community or world, use it and think outside of this Ruby on Rails box. One thing I would love to urge you is to actually go and watch the video. Not this one. Watch the video on ServerEngine. Just a hint, there is an English version as well. You just have to look for it. But if you type ServerEngine on YouTube, there are like 2 videos, because it's really not that popular as it should be. But it deserves the credit. And guys, write a game. Really, it's fun. If you ever thought, I don't know what should be my side project, write a game, really. I've written games for my kids. I've written games for myself. And it's just fun. It's not that difficult and can learn you quite a lot. And if you'd like, please check out the Raise Permanent Job Jam and let me know if you'd like any features. Because I've actually written it for a project that I'm in and a bit for myself, because it has been my idea for quite some time. But if you find it useful, please just let me know, and let me know if you need any features. So at the very last step, before I leave you, I would like to show you one more thing. If you have a phone, I welcome you to join. You will see yourself at the screen. This is a browser window, and I will move myself to make some. Oh, we have first guest. Since we have multiplayer mode, now your character is marked with this red area. You can click on the white box. If you click at the bottom, you will go down, or up, left, and right. Here we go. I've made it a bit bigger so that it can fit more people, because it was like 8 by 3. Guys, if you catch a dragon, it's -2 points. So you don't want to be staying at the right. Yeah, I can imagine. Okay, thank you very much. That was the presentation. If you have any questions, go ahead. Macie?
Przemek.
Hi. Oh, sorry. So I've got a question for you. You've shown that in early examples of your Rails permanent job, that the jobs has 1 second delay, and then you added after job with 0.03 to have this loop. But I thought that it was implied 1 second. Like where this 1 second delay came from?
The original, the one, if I don't explicitly define after job as 1 second, it defaults to sleep once to a lambda, I think, of sleep 1 second. So it's defined in the source in the code of the gem itself. It might be nothing, but you can easily override it.
Okay, I see. And the other question, what happens if you pass an array of 3 jobs and define it to 4 workers? Does each of them get 4 workers, or they share this pool?
Each worker will execute those 3 jobs one by one. So the first worker will, if you have one worker, it will get all the jobs and it will run it sequentially. If you run another worker, that will also run those sequentially. Like each worker is the same. They do not differ in any way. It's not like I'm moving the jobs around into workers. It's like if you want to have a worker that executes 3 jobs, then you create it like this. And if you want to have more workers, each of them will execute 3 jobs. Just if you want to do it differently, you have to run 2 processes, because in here each process shares the source code of all the others.
So you'd have 3 concurrent workers that goes through 3 jobs, right?
Yes.
Okay, thank you.
Any other? No. Okay, if you'd like to play some more, join me at the after party.
Is there a way to guarantee order of running these jobs, or just array of jobs?
It's an array and it's sequential. There is no threat they wouldn't be executed one by one. It's just an array.
Okay.
No magic. Sorry. All right, guys. Thank you.